Hello dear students, today I will start Coulomb's law, which is related to electrostatic. According to Coulomb's law, force of attraction or repulsion between two static point charges is proportional to the product of both charges and inversely proportional to square of distance between them. This force acts along the line joining the two charges and depends on the nature of medium. Once again, force of attraction or repulsion. It means when the two like charges feel repulsive force and unlike charges feels attractive force. Between two static point charge, static means when charge is in rest. Point charge means the charge is concentrated in a very small volume or spherical body, just like considered as a point charge. After we will discuss why spherical bodies is known as point charge, right? Okay, is proportional to the product of both charges. Suppose this is a point charge Q1 and another is a point charge Q2. Suppose the nature of this charge is positive and this is also positive. So force between them is repulsive force. It means both are repelled to each other. And suppose one charge is positive and another charge is negative. Suppose the magnitude of this charge is Q2 and this charge is Q1, and the force acting between them is attractive. So we can say like charges are repelled to each other and unlike charges are attract to each other. So the meaning of this line is the force of attraction or repulsion between two static point charge is proportional to the product of a square product of both charges. Like this, suppose the force of attraction or repulsion between them is F is directly proportional to Q1 and Q2. Q1 is the magnitude of one charge and Q2 is the magnitude of another charge. It means this is the product Q1 and Q2. And similarly, suppose this is in equation 1 and another way F, now we have to read second line, and the inversely proportional to square of distance between them. So F, force of attraction or repulsion, is inversely proportional to the square of the distance. Let the distance between them is R. We have to take here magnitude only. In vector form we will discuss later, and the distance is separation between them is R. Okay, this is in equation 2. Is inversely proportional to the square of distance between them. This force is acts along the line joining the two charges and two charges. It is a very important line. The force is act along the line. That means the force of attraction between two charges or repulsion between two charges is acting along their line joining. That means force always acting in this direction, like this, always acting in this side, not acting in this form, not acting in this form, is always acting in the along the line joining between them. It may be attractive or may be repulsive, just like if the charge is same charge or like charges, the force is repulsive, and unlike charge, so force is like this. In this case, this is the unlike charges and the force of attraction is acting in this direction. Okay, now we have to add, and next case, and depends on the nature of the medium. Suppose two charges, the medium between them two charges is a air or vacuum. When we change the medium between two charges like water or any other dielectric medium, the magnitude of force should change. That means the force is depend on the nature of the medium. Okay, so we can add equation 1 and equation 2. We can write here F is proportional to Q1 Q2 upon R square. So we can remove the proportionality sign. We can write in this form F is equals to we use here proportionality constant K, magnitude of this Q1 and magnitude of this Q2 upon R square, where K is called proportionality constant. K is called proportionality constant, and magnitude of K is 9 into 10 to the power minus 9 into 10 to the power 9 Newton meter square per Coulomb square. This is the magnitude of K, proportionality constant, for air or vacuum. Value of K is equals to 1 upon 4 pi epsilon 0, where epsilon 0 is called permittivity of free space or vacuum for air or air. The value of epsilon 0 is equals to 8.854 into 10 to the power minus 12 Coulomb square Newton meter square. Okay. Suppose we can change the medium. Now we can write it this formula in this form: 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. This is the force between two charges in air or vacuum. The magnitude of this force is independent of nature of charges. So, I mean to say, when the two charges having same nature, the force of attraction or force of repulsion between them is equals to when the two charges having same magnitude but opposite nature. Okay, so we can say this force is independent on the nature of charge. Magnitude of the force is always equal when the magnitude of charges are same. It is independent of nature of charge. When we say this is this force is acting between the two charges in air, so we can write here Fa. And if suppose we can change medium between two charges, we can write, let be the separation between them is R, magnitude of the charge is Q1 and Q2, and the force, and we can insert medium between the two charges, or in another way we can say the charge is placed between the two mediums, in between medium. Okay, so new force acting between them, F dash, is equals to Q1 Q2 upon 4 pi epsilon R square, where epsilon is the permittivity of medium. Permittivity of medium. And the relation between permittivity of medium and permittivity of air can be represented by permittivity. Epsilon is the permittivity of medium and epsilon naught is the permittivity of free space or air. Is the ratio of these two terms is known as relative permittivity of medium. This is also known as dielectric constant, which is represented by capital K. Dielectric constant. So we can write epsilon equals to epsilon naught into epsilon R, or epsilon naught into capital K. Now we can put these two values in this formula. So we get F dash is equals to Q1 Q2. Let me indicate this is the equation number 1. Sorry, equation number 3. 4 pi epsilon 0 into epsilon R into R square. So F dash is equals to Q1 Q2 upon 4 pi epsilon naught R square into epsilon R. This is equals to equation number 3. So F dash can be written as F upon epsilon R, or F upon capital K, because ellipson R is also known as capital K. Capital K is called dielectric constant, right? Now we can say the force can be changed by medium. So the meaning of this line is the force is depend on the nature of the medium. Means when we increase the medium, when we increase the medium, the force of attraction or repulsion between charge going to reduce, okay, by the term of F into 1 upon K times. That means two charges, force between two charges is reduced to 1 upon K times by inserting medium between them, okay. The maximum force, this is the maximum value of K for air or medium. That means the maximum force applied between the charge in vacuum or air, when we insert medium, the force continuously reduces. So we can write here the value of capital K is equals to approximately 1.003 for vacuum. Value of K is equals to 1.006 for air. Value of K is equals to infinity for metal. That means the force between charges in the metal is always 0, because value of K is infinity, then force should be 0. That's why we can say the electrostatic force between two charges is always 0 inside the metal. Now we can, this is the relation between force. Now we can write in another form, force in air. So F dash is equals to F upon capital K. So F is equals to F dash into capital K. This is the relation, means force in air upon force in medium is equals to K. This is a very important formula. This is the ratio of two forces between medium and air and medium, okay. Now we can discuss next topic, vector representation, vector form of forces. First case, in polar form. Suppose two charges have magnitude q1 and q2, q1 and q2. Separation between them is r. In form of vector, we can write, suppose force applied on charge 2, force applied on charge 2 by charge 1, then that means the direction of force is this. This force is known as force on 2 by 1, and the distance are taken from R to 1. Distance are taken R to 1, 2 to 1. This is the vector form. So we can write in the form of F21 is equals to K Q1 Q2 upon 4 pi epsilon 0 R 21 mode vector square. This is the equation number 1. Now the second case is force on charge 1 by charge 2. It is called F12. Okay. Now we can write F force on 1 by 2 can be written as Q1 Q2 upon 4 pi epsilon 0 mode of R12 vector square. In this case, Q1 and Q2 are the magnitude of charges. These are scalar quantity. 4 pi is an angle. Epsilon 0 is a scalar quantity. And here R is a vector, but in mode form it is also known as scalar. So we can write here the direction of force can be given by R21 cap. And in this case the direction of force is R12 cap. So this is the called unit vector which shows the direction of force. Also in this case R12 cap is the shows the direction of force. This is equation number 2. Now in this case we can write F12 vector is equals to Q1 Q2 upon 4 pi epsilon naught R12 mode R12. According to vector, R12 vector is equals to minus R21 vector, or in another way R12 cap can also written as minus R21 cap. So we can write here F12 vector is equals to Q1 Q2 minus R12 is equals to minus R21 cap upon 4 pi epsilon naught R12 vector square. So we can write minus Q1 Q2 R21 cap upon 4 pi epsilon naught R12 mode. One thing, R12 mode of R12 is equals to mode of R21. That's why F12 this term is equals to, here is this is equals to, because this is a magnitude, that's why the whole both values are equal. So we can write in this form can be F21. Okay, so F12 vector plus F21 vector is equals to 0. Now we can say Coulomb's force, or the force between two charges, is obeys Newton's third law. Every action has equal and opposite reaction. Okay, it is a very important condition. And one more thing, force, this force is also inversely proportional to R square. That means it obeys the inverse square law. That's why we can say Coulomb's force is a central force. It is a central force. Central force. This is the vector form of Coulomb's law in polar form, polar coordinates. But now we next topic is the vector form in Cartesian system. The vector form of Coulomb's law in Cartesian system. Suppose we have two charges, one charge is this and another charge is this. This is the origin. Position vector of this charge is R1 vector. Suppose the magnitude of this charge is Q1 and this is Q2. Okay, the separation between them is R. This is the position vector of this charge is R2, I cap, J cap, K cap. It is a Cartesian system. So this is called the force applied on 2 by 1 is denoted by this form. So it is force F21. Okay, now the distance is R2 minus R1. According to vector's law, vector triangle law, triangle of vector addition, R1 vector plus this is also known as R21. R21 is equals to R2. according to triangle of vector addition, right? So we can write R21 equals to R2 minus R1 vector. Okay, now we can use this formula. So we can write here F21 vector is equals to Q1 Q2 R21 vector, sorry, 21 cap, sorry, upon 4 pi epsilon 0 R21 vector square. This is also known as Q1 Q2. R21 cap is here. Similarly, this can be written as R21 cap equals to R2 cap minus R1 cap. This is the unit vector and this is the vector. Unit vector R cap is represented by R vector upon mode of R. Okay, so this is the magnitude, there is no direction, and the direction of this is equals to this. That means unit vector is defined as that type of vector which has unit magnitude. Okay, when magnitude of R is unity, so we can say R vector is equals to R cap. So Q1 Q2 equals to R2 cap minus R1 cap upon 4 pi epsilon 0 R2 minus R1 square. Or we can also write in this form Q1 Q2 R2 minus R1 vector upon 4 pi epsilon naught R2 minus R1 cube. We can write R2 cap minus R1 cap is equals to R2 minus R1 vector upon R2 minus R1, right? So we can put the value of this vector in this form, so we get this equation. Similarly F12 can be written as Q1 Q2 R1 minus R2 vector upon 4 pi epsilon naught R1 minus R2 cube. This is the magnitude, that's why there is no direction, and in this case we can write in this form minus Q1 Q2. We can use your minus, so we can change the direction, R2 minus R1 upon 4 pi epsilon naught R1 minus R2, or minus Q1 Q2 4 pi epsilon naught R2 minus R1 cube, and here is R2 minus R1 vector. Previously I can show, I am showing to you कि where is R2 minus R1 mode is equals to mode of R1 minus R2. So we can use this relation is equals to F21. That's why F12 is equals to minus F21 vector. Now in the Cartesian system, the same result can be obtained by F21 is equals to 0. Okay, so we can say here कि Coulomb's law obeys Newton's third law. Newton's third law. So one important thing is here, Coulomb's law, the main things are related to Coulomb's law. Coulomb's law state force of attraction or repulsion between two point charges is proportional to the product of both charges and inversely proportional to the square of distance between them. And this force acts along the line joining of two charges and depends on the nature of the medium. And very important thing is Coulomb's law obeys Newton's third law, and Coulomb's law obeys Newton's third law, and it is a central force. So for today's, we conclude the class, and next topic we will discuss on next class. Thank you very much.